How many of you have been to an IETF meeting before and have never seen a note well? So what happened so I don't understand why that's still up. The application is closed.
Yeah, but it's not on any of the other screens.
Okay. In case you're wondering what this is up front, that's my driveway. But, okay. Folks? So I really don't understand why that's there. There we go. Much better. Ta-da, the right thing happened. Okay, so okay, note well, everybody please note. So now, switching computers here. This is the agenda we have. Our agenda is blue. So this is the agenda that we have today and tomorrow. We have 3 working group drafts. We have George Michelson with basically some marketing information about the IPv6 market, which I find very interesting. We have Fred Templeton's draft tomorrow morning. If we have time, I'll move that forward to the end of the meeting today. And then kind of AOB, we have 3 other drafts that people have brought to me within the last week or 2 weeks and asked for some time if we have it, and well, we have it, so fine, we have some AOB there. Anybody want to bash the agenda? Seeing none, okay, good deal. Jen, I asked you to come talk about conditional RAs. Could you give us 2 minutes on what's happening with that?
So initially I had an ambitious plan that probably we should publish it as the cluster with a big routing multi-homing draft because it has a lot of justifications why Slack, why not DHCP or ICMP errors and so on. But looks like routing draft is kind of stuck in the process. So I think actually the routing draft is now currently an informative reference, so probably it doesn't make sense to wait for too long. So I think Warren can correct me, but it's now in telechat, right, for conditional arrays. So it's waiting for final reviews.
Okay. So, yeah, it's been sitting for a while waiting to get into the ISG, and I guess it finally got there. So.
It's been waiting because I was hoping that we can move with routing draft faster, and I gave up eventually. So.
And that guy there made it happen. Yeah. So, okay. Thank you much. With that, now let me show you something that I find interesting and amusing. Switching back to my computer here. There we go. Okay, so now what I'm showing here is the statistics from Eric Banks' page, but they're Google statistics. Folks that they say, as of this morning, as of a few hours ago, 5% or more of the traffic that comes into Google from these various countries is using IPv6. So these are kind of the big guys in terms of using IPv6. That blue line across the top is, of course, Belgium. In the lower right-hand corner, that green line that's going up almost vertically is Taiwan. And we've kind of got everyone in between there, which I find particularly interesting. And then looking just at the top 10 countries in that listing, we've got Japan, which seemed to be for a long time kind of not moving and seems to be doing reasonably well at this point. Uruguay, which, why? I don't know, but they're there. We'll ask the guy from Uruguay. Greece and so on and so forth. So we're having a fair amount of fairly interesting stuff there. The thing is, Google runs IPv6. And when you do this kind of a graph, you're saying that the packet went all the way from the host through an ISP, through another ISP, wound up in the destination network, and actually found a computer, and they all ran IPv6, and life is good, right? Should there be any break in the path, it doesn't look like that. So this makes great marketing material and is actually deceptive in an interesting way. So now, George, where are you? Tell me George Michelson is it? There he is. Okay. So George has been looking at that and the implications of that. And so here you go, George, and you get this thing. And by the way, as George is demonstrating here, if you're a speaker, there's a pink box up here. Somebody will shoot spit rods at you if you step outside.
So I'm ShamWow. I'm ShamWow man. I'm Dentel. I'm here to sell you on the future. So we're working off a figure that says the world capability is somewhere around 18%. And that means can, not does, just means can. It's based on a sampling technique, it's web measurements using recruited ads. It's about a 15 million a day sample worldwide. We have to do some adjustments because of the way the placements happen. We do some weighting. There are various issues with over and under sampling. It goes to the error rate. A lot of other people put the rate higher. So there's a community that is saying it's north of 20. We have a view around how we do an adjustment reflecting the internet population based on stats that get reported quarterly back to people like the ITU and the UN. So we do an adjustment based on our beliefs about users. You can view it as a low side count. You can view others as a high side, and we're bracketing things. I think that's not a bad view. Anyway, let's have a look at the ranking of the economies seen worldwide in this mechanism above and below 18%. So the top set, if you look above there, that's a very interesting mix of economies that are consistently visible with very high rates of penetration. Look at India, 59% IPv6 capability. That's amazing. I mean, that's an extremely large economy. That's a very large population base. We are talking large numbers of people whose lives now currently depend on IPv6 fabric for their daily internet. Or New Zealand, 20%. That's a tiny country. Have more sheep than people. They're managing quite comfortably to get 1 in every 5 of the sheep IPv6 connected, which is a phenomenal outcome that we should be very proud of. And if you run through the list of countries, it's a very interesting mix of economies. So you look down below, and also these are really fascinating economies. They are just spread all over the economic footprint. Anyway, let's come back to that in a minute. So how much of the world V6 is represented by each of those economies? What percentage of the population of people who are in the game is in the game? Okay, so let's rescale it. It's no longer about how much V6 in an economy, so it's not India is on 59%, it's of the 100% of the world of V6, what percentage of that is coming out of India? And I'm going to look at the top 15 because after that it just gets a bit rubbery. Okay, so who wants to play a guessing game? What do you think is the big blue economy? Hint, it's India. So India is contributing about 44% of the globally visible V6. If you are in the business of doing international connectivity and you are supplying service to the world and you do V6, and if it was genuinely international, 44% of your V6 hits would be coming out of the Indian user base. Now think about this. Think about this as Dentel man, as ShamWow man, as money, That's where the money is. The money is in India, right? The money is the middle classes in India and their ability to project V6 traffic at you. Yes, Lorenzo.
For clarification, 44% of what?
44% of the notional 100% V6 enabled worldwide community.
Measured by?
Random ads placed with a very large international advert placement agency.
So basically proportional to that agency's traffic.
Yep. And if they fail to achieve ad penetration worldwide, obviously we will miscount. So if there is no viable market in India for double-click, it would distort the numbers. That is an absolute given, yes. Warren.
So, Warren Corey, following up from that, and also somewhat weighted by where those ads happen to get displayed, which I think the ads are set for as cheap as possible.
They are set for as cheap as possible, and they are also set for the following 5 magic keywords: funny, cat, video, hot, car, music. So if Kim Kardashian puts a video out about dancing cats with an amazing car crash scene, we are going to spike for ad placement. But it's generics, right? Okay, so second rank, it's USA. 20% of what we're seeing worldwide in V6 is coming out of North America. Brazil, would anyone have predicted that 6% of what we're seeing is coming out of that economy? By the way, that is a huge economy. There's an interesting story there that we can look at. Japan is 4.7. That's kind of cute because there's been a long time of people saying Japan is not going as fast as it should do, but their net contribution globally is actually quite high. Germany is 4.2, and coming out of nowhere is China, which is a moment we might also talk about, and the rest of it is kind of a bit small. So in terms of these people's economic rankings, if you were doing a grid of what's their economic contribution in GDP terms, it would not look like this, right? Shane Kerr. So
This is with your ad placement technology,
this
right?
is with our ad placement technology from Google. From Google, yes.
In China.
You have to understand that what China do to prevent the awesome of Google from reaching the planet is they dick around in the DNS to hide names that say Google. What they don't do is prevent packets flowing to the IP addresses of the Google ASN necessarily. And double-click, which is what the ads appear as, does not necessarily get filtered by the GFC. Necessarily. I will add that we have from time to time said, wow, we think these figures from China are really weird. And when we compare them with internal figures in China, we tend to see that the internal figures match. But there is room for error. There is room for error. Nothing is certain. It's Dentel, man. It's ShamWow. It cleans your screen like nothing else.
Okay, cool.
Lorenzo.
Lorenzo Cudi, I think if you take similar traffic sources, but you take away the fact that the ad needs to be as cheap as possible, you end up with the US in first place, Japan second place, and India after that.
That is very interesting. But do you adjust for their population size?
No, this is like, it's the same as you do. It's
No, our numbers are comped up to reflect what we think the GDP of the population is, Lorenzo. You have to go back and do an extra column of dither on this. It's not just the randoms, it's the random against their computed population in internet broadband terms.
That's not what you said when you explained 44%.
Yeah, well, the slideway's lying. No, seriously.
So you came here and lied to us.
Did I say that? Did I say that? I would never say that. No, but Lorenzo, it is slightly more complicated than just the random ad. It's the random ad distribution applied to the inferred population of internet users to come up with their population of V6 users. Right? We get a sample and it says we're seeing this much relative V6 in India, and it's currently, let's say, 60%. And then we have a declared broadband population of India as 1.7 billion, and we have a population of America as 260 million, and we do the maths to scale those relative V6 numbers to a notional 1 million world population and then pie chart it. Do you want me to talk to you about this over beer? Because, I mean, it's arguable the numbers are bullshit, but this is what I'm doing.
I'm not gonna confirm or deny that assertion, but what I will say is that here, the numbers that I see here
Yeah.
are that 44% is more like 5%. So
I'm
what
just-
FMV?
Yeah, but I'm just saying, I think there's a reason why you see that. Hey.
Hey, Tom
Hey.
Farley, Apple.
Hi, Tom.
So, question on this. So I appreciate how we're scaling it for population and how many
Yep.
people we have access.
Yippity yep.
Maybe to come closer to some of the numbers we're seeing here,
Yeah.
should we indeed also be scaling by some value, which I am sure we cannot get? How much usage of that internet connectivity the population has?
Yeah.
Because if I look at the number of connections that are made daily by high school kids in the US, that's probably a lot higher than people who are working in India, have better things to do with their time.
Remind me to come back to this when the slide comes up with India. Okay? So, just to come back to this one, if you take the economies and we start to say, well, how do they fit into a group? Can we pattern group behaviors here? And you look at, say, the G8, all the G8 show up on the board of people who are V6 active, but two of them, Italy and Russia, really show down low, but the rest of them is kind of there. So you get a moment where Romatre, you're really selling the card there. But they're all there. Okay, G20, well, they're all there except for Indonesia and Turkey, and actually that matters because Indonesia is 240 million people. If they got their act together and deployed V6, the worldwide population of 6 would rise enormously. Turkey is a large economy. The fact there's no 6 there is kind of really weird because you think they'd get the program. Also, if you look at the spread of economies, yeah, all of the G20s on the board but 2, but they're not all doing the same. And that's the principal moment here. There's no rational story that says, oh, if you're a G20 economy, your V6 is fantastic. No, sir, no such story. OECD, it's similar. There's no clear signal of who is or is not in the game because of membership of an economic grouping. And what I'm trying to say here is there isn't a specific economy sector you can point to and say, V6 is happening because you are a member of the developed Western economies. That's not true. V6 is happening because V6 is happening. The logic here is around other things. It's about your investment strategies. It's about competitive tensions in your own economy. It's about the regulator. It's about stuff that isn't about, I know in advance. It's kind of random. But there is this concern emerging, for me at least, the idea that there's a 2-track internet. There's people who don't seem to be moving, and there are people who have moved, and that means everyone's thinking about there being 2 kinds of internet for a long time. Now, this is no secret. We've known this. We talk about this all the time. But the thing is, it looks like it really is a thing, and that's kind of a worry. So I kind of like 6. I like about innovation, and I think incumbency. I've got my assets. I've got my V4. I don't need to worry. Nothing can happen to me. Well, you know, stuff can happen to you, and that's what's coming up next. Okay, so let's drill down into these economies a bit. Let's look at them inside. Let's look at per AS statistics, which is an approximation for eyeball share based on our random distribution model, and let's see what things look like. So there's 2 charts I'm going to put up side by side. This is a MECO chart, and the vertical size is how much we think we saw of you. And the horizontal dark is how much of you we saw 6 capable. So the other chart is the timeline of the ASs we saw, and this is India. So that big box on the top, that is Reliance. Reliance did a clean build. They put out an entire clean build LTE solution to the door nationwide that was V6 enabled day one. And they also offered free voice if you took their minimum data plan. And if you look at the orange line, that is Reliance, and that is their scaling of V6 capability. And they basically hit 80 to 90% penetration pretty much inside the first year of deployment. And they single-handedly took India into world rankings. But then, if you look across the line, there's this weird moment where Bharti and Hutchinson, which is actually 2 ASN, it's ICL and it's Hutchinson Telecom, they actually reacted in time. So if you look across at this, there's a time delay, and then some other people say, I think we might compete in this market space. I think we might do something here. And they actually started deploying V6. Now, I'm not going to say it's an economic reaction. I'm not going to say it's competition in there competing in V6. But there is certainly signs that after Reliance did their play, the other ISPs decided they needed to do something. Okay, now here's the thing. It's not on this chart. But when Reliance started this back in 2015, on our measures, they were about 15th. And by the end of it, using the Google random machinery of ad placement, they are the number one provider in the economy. And they never said in their advertising, use us, we have V6. It was not a moment, because V6 does not figure in selling telephony to the Indian masses. What figures to the Indian masses is, I can ring my mother for free and I get a data plan. So to that question, but what meaningful percentage of these users are doing V6? Well, I have to tell you, if it's Reliance, all of them, because it is a pure stack V6 solution. If you're online in India and you're using Reliance, and PS, 50% of the market looks to be there, you're using V6. So I would say it's pretty solid. Okay, this is America. Now this is a weird story. I mean, look at this line. You have some early movement from some ASs that basically hit 90% day one and stay there. And you have Comcast doing a kind of disordered rise up towards the full state, although there are some questions around why is it not 100%, because we know Comcast is meant to be fully deployed. Thing is that they have some legacy gears that are never going to get there. And they also have some issues around commercial service that's hidden behind the AS that's also providing domestic. And we all know that the predominant usage going on here is essentially domestic use. So there are kind of stories there. Jared.
Hi, George. Yeah, regarding Comcast, there's also a lot of people, small business market.
Yep.
They do give V6 to those people. But traditionally, they'll just plug in a little CGN box.
An appliance.
Yeah, they'll plug in their little Netgear or whatever, and in your marvelous dentist shop,
Yes.
you don't get V6 on the backside because those are not default enabled.
Are you talking about my backside in V6? Wow, okay. But
I
I mean,
can
this
tell
is
you
what-
that the Netgear 8500 does, because that's what I use.
Right, but there is the problem here that small business taking service off someone does not necessarily deploy 6, and that's the problem. The SMEs are not there. Warren.
Yeah, I mean, also, all their CPE does it, but their cable modem doesn't, which is another long ongoing issue and fighty thing I've had with them. But
So where I wanted to go with this diagram is that there is actually quite a lot of competitive tension in who's got eyeballs in America. It's not a one AS story, right? This is not Reliance. This is a different economy with a different pattern of competitive tension. In the left-hand box, the MECO chart, there's different levels of deployment. But there is 6 written across the story for the USA, and at different times, different players have decided to deploy. It's heading to an interesting place. Okay, this is the Brazil story. What I've been told by Carlos, my friend from the LAC community, is that there's actually a national agenda. And what you're seeing here is a concerted move in a federated structure for all of the players to move the market, broadly speaking, in concert. So this is a number of large cable deploys in large capital populations, Sao Paulo, Rio, the States, making their move. The interesting moment there is it includes Telefonica. And here you have Telefonica doing a massive V6 play in South America, and they're not doing it back home in Spain. But Telefonica have religiously enforced centralized planning. You can't buy network gear in South America without approval from the Spanish head office. Go figure. It's weird. Eric.
Yeah, questions. Am I reading this correctly? The Brazil line is lower than all of the other sort of called out?
Because the pullouts don't reflect the market share. They're about that individual AS's percent capability. It's not been comped into its percentage contribution.
changes to ensure that the operator has control over the different transition mechanisms. We have worked different changes in the UPnP section, and then we improved some text, clarifications, corrected ID needs, and so on. So if I try to look at the differences between RFC 7084 and this document, there are some new general requirements. One of them is supporting RFC 7608. That document, of course, is newer than 7084, so that's the reason for that. In the LAN, we are now requesting as a must the DNS proxy. This is something that we checked with most of the CP vendors, and it's something usual, so it's not a requirement that will create a problem for CP vendors, but most of the transition mechanisms require that. So the ideal way to do that is, instead of enforcing it in every transition mechanism, make it a general rule for the LAN. Also, in 7084, it was considered 6RD. We don't say anything about 6RD anymore in this document, and we have a couple of new requirements from for DS Lite compared with what was asked previously in RFC 7084. We have a new section which is transition requirements, and then we have several of them. One of them is that the routers must support RFC 8026, which is a prioritization mechanism for selecting which transition mechanism the operator want to enable. And this is basically done in order to allow them to move from dual stack, for example, to an IPv6, IPv4 as a service transition mechanism, and so on. So this has been discussed in the mailing list, and we find a way to, without any new DHCP option, just using existing options to do that. We also ask the CP to support graphic user interface and or CLI. We request also that the CP must check for all the available configurations for all the supported transition mechanisms, but not enable them at this step, because that will be enabled depending on the options from RFC 8026 later on. And this is transition requirement 4, which is just looking at what the ISP is supporting and then enabling that specific transition mechanism. And I think that's it basically. Okay, so then we had the specific requirements for 5 transition mechanisms. One of them was already part of 7084, which was DS Lite. So now we have, in addition to that, Lightwave for over 6, 464X LAT, MAP-E, and MAP-T. And then we have IANA consideration section, because 464X LAT was the only mechanism that didn't have a specific option, but there was a previously defined option for NAT64, which is 113, and we are reusing that option, so not creating any problem, to allow that prioritization mechanism to go through and select which transition mechanism is being used. And that's it. I have some backup slides, but if we have questions over that, I can go through them.
Well, yeah. So I've got a bit of a chair discussion I want to have, but
Yep.
let's take folks at the mic first.
Lorenzo Culidi, why do you say that the CE router must comply with 7608?
Must comply with?
7608, go a few slides back.
Oops, this is not going back. Okay. Whatever. It goes back or not?
That one.
7608.
Yes, why?
We are just saying that the length of the prefix is a recommendation of, if the router want to use something different in the LANs, it's possible to do that. That's what the document, I think it says. I don't recall right now its specific details, but I think it was that. So it's a parameter, basically, the prefix length, right?
So that says that forwarding should occur on all prefix lengths. I'm not sure what you're trying to achieve with this. Do you know what you're trying to achieve with this?
I don't recall right now the content of the 7608. I will need to look into that. But I think it's basically saying if you want a different length, you go for that. Yeah.
Hi, Jared Mach. So Lorenzo, I think what he's trying to say is that the user should be able to configure it and that they shouldn't be stuck with a fixed 64.
Exactly.
They should be able to configure it if they want to, not that they.
If you're using a Slack, that's fine. But if you want something different, why not?
Then that's what you should say in the document, and you should say that the router must allow the user to configure prefixes that are not 64, and then we should discuss that.
Well,
No?
I think it's easier to do the reference to the document that is saying that instead of
That's
repeating
not
everything.
what that document says. What that document says is if you were forwarding a packet,
Yeah.
it doesn't say anything about subnets, it doesn't say anything about anything.
Okay. Maybe I
Right,
am confused
okay.
right now. I don't recall the content of 7608 right now.
I can tell you what the
Yeah.
content is. If you're forwarding a packet, you must be able to forward it to a subnet of any length from 0 to 128.
Okay, so that's it. It's not the other thing. Yeah,
Which brings me
you're
to
right. I
another
recall it
question.
now.
What are
Yeah.
you trying to achieve with this?
Yeah,
The
yeah.
real target of 7608 in that context was chip vendors like Broadcom.
Yes. That's correct, yes.
Yeah.
So I don't think it belongs here. And if we want to say that the user should be able to configure smaller subnets than 64, then that's what we should say in this document.
No, it was not that. Was the forwarding of the different
But
brackets.
if you
Yes.
can't configure it, then why do you want to forward it?
Okay, so
You
so
want
we
to
need to say
forward
both
it if
things.
it's advertised to you in routing.
I'm sorry?
If it comes into you in routing, you want to be able to honor that.
But it must never because we have requirements, at least in HomeNet, that says that we should at least delegate a 64 to the home, possibly more.
Yeah.
And all our guidelines around it, like delegate at least a block of many 64s. And so if we do this, then that's like entirely contradictory. Right?
Okay, I
So
think the conversation that you're having belongs in sixth man.
No, not really. I think I'm asking about whether it's necessary to place this requirement on vendors, and why are we doing that?
I don't recall who actually suggested this. I recall that in my original versions, we didn't have that, and somebody suggested that, but I don't recall right now the details. I will need to look into my notes to check about that.
Does anyone remember why we added this? Because if not, I'm going to propose right now that we remove it, and if no one objects to that, we can remove it.
Yeah, I just trying, if you think we should have it, then it would be nice to document the use case, because I'm thinking of CPE about some as device which has uplink interface to ISP in some local networks. It's not, I cannot understand why that device must have a route in the routing table, which will be like of any prefix length. It most likely would not be the case, right?
So that will be necessary if, for example, with DHCP V6, you allow something different than /64, for example.
So I'm not convinced it's the must here, right? Yeah, so I'm like, I think we either need to remove it or clarify this.
Okay.
Okay. So the mic lines have emptied. As I said, I have one draft that I think we're about ready to go to working group last call on, and that's this one. So I'd like to do that. So first question, do you agree? Do you want to go to working group last call on this? If so, nobody wants to go to working group last call on this. What? I asked you to hum. If you think we should go to working group last call on this, please hum. Okay, do you think it's not ready for working group last call? Please hum. Yeah, okay. In that case, then let's not take it to working group last call, but we will pose a discussion.
Maybe have a discussion in the list
Well,
about
we'll
this
definitely
comment
have-
from Lorenzo,
We'll
and
definitely
then
have a discussion
in
on
another
the list.
version, we check that again.
We'll definitely have a discussion on the list. Now, one other thing, I'd like to get 2 reviewers on this draft, 2 people to read it through and comment to the list on what they find or don't find. Can I get 2 volunteers to review this draft? So, who have we got?
Tim Winters, UNHI, I can review it. Thank you.
And another? Can I get a second one? Okay, so Ron. So fine. So great. Now just a minute. I was going to ask for 2 reviewers on Russ's draft also. Can I get 2 people to volunteer to review Russ's draft? Somebody?
Rick, could we shame you into it? Shall we?
Okay.
I had a question about this document that I remember somebody, I think it was Barbara, observing that it's going to put pressure. This document says you should implement at least 5 different transition mechanisms for V4 over V6. And I recall her position on that was that would increase costs for CPE manufacturers, which are already particularly sort of low margin operations, and would either result in nothing or very buggy implementations that would then, oh, there you are. I would just wanted to, I didn't think you're in the room, I just wanted to see if that had been resolved.
I think, well, we have 2 of the co-authors of the draft are CPE vendors, and they decided that this is not actually that much extra cost, and they have already implemented it. And the main problem is that if you are a big ISP, a big operator, you go to the CP vendor and they'll tell them, I need this, but the smaller ones cannot. And the other thing that is already in one of the annexes of the document is that the data plane is the same for all of them, basically. There are two data planes, so 2 different data planes and so on. So I really think, of course, there is an extra cost for testing any new feature in any device, that's clear. But in general, implementing is not that much problem as we heard from CP vendors.
The CP vendors, were they boutique CP vendors that sell things on the shelves that cost $100? Or were they CP vendors that sell to, there you are. Or were they, because the question I think is if there are CP vendors that only sell to ISPs only, if they don't have the margins, then this document will make no difference.
No. If they are selling to ISPs, they don't need to implement all of them. That's explained in the draft.
Well, so this started out with you quoting Barbara. Maybe we should let Barbara get a word in.
Yeah, since my name was used. So my view on how this gets used, from a pragmatic perspective, once it's published, is you've got basically 2 uses for it. One is, as an ISP, you know how evil we are. I am perfectly happy to pick and choose, if there's something I want from my vendors to say, do this, and just kind of, I'm not expecting you to be compliant with everything. This is all I'm interested in. That's fine. Now, then there's another set, which is kind of your run-of-the-mill CE vendors. Now, they can read this and say, I'm really not willing to do all of that. And that's fine. All it means is they cannot claim compliance to the specification. Then there's the ones who say, I am willing to do all of this, in which case they can claim compliance to the entire specification, say, we're extra special good. And I think that's a really good thing to be able to say. And so, to me, it's kind of, I'm perfectly happy with it.
Thanks. Absolutely link. So I don't know if the bug implementation so-called by render is referred to my implementation, but from the hardware cost of view, it doesn't much. However, what I was suffer was actually the cost that somehow I try to, on those time I try to teach or to guide my OEM vendors to implement all this stuff. Then no way they're going to read all those RFCs. That was a sort of the reason why I support Jody for this work. Yeah, from a cost, from memory kind of hardware cost point of view, it doesn't really much. So, next one? Okay, so yeah, let's move on to the next one. Okay, how many people has read this document? Very few, okay. History of the document. I started this as an outcome from a discussion in the IETF mailing list because there was a comment that we should have only IPv6 and not 64, and then I suggested 464XLAT in that case because there are some applications still that will need that. In the discussion then comes the point about DNS64 that may break DNSSEC. I think it was Christian Utema said we should never have DNS64 and we can perfectly use 464XLAT without DNS64. And in fact, it's something that I am trying in some big trials with some operators. So I documented that in a document considering at that time only 464XLAT, and it was presented in IETF 100. And then the working group suggested let's go for an overall NAT64 deployment guidelines document. So that's what I did. Unfortunately, in the last IETF in London, the presentation was very, very quick. We didn't have time, and I didn't got almost comments. But anyway, in the last months, we had some clarifications in the list and some points that I want to note. This is not a discussion because some comments I received, I think, in the list or in private. This is not a discussion about NAT64 versus other transition mechanisms. This is not a discussion about DNSSEC, but it's important, and there is a lot of text in the document to reflect that. And what this document is trying to do is, if you already decided to go for something based on NAT64, then here are your choices in section 3, which I call scenarios, and then what you should take care of to deploy those scenarios, which is section 4. So basically, the document has an introduction which is talking about 3 main issues, which is DNSSEC may break DNS64 may break DNSSEC, NAT64, DNS64 don't work with literals and older APIs, NAT64 alone does not work for IPv4 only host or applications. We all knew that, but the people that is going to read the document maybe not. So we need to make sure they understand that situation. So looking at the scenarios, what I have done is looking at what new scenarios have been coming to the market since DNS64 was published. And in that document, they talk basically about only 3 scenarios. Now we have new ones, including all those based on 464XLAT to comment. And I am looking at the document from the perspective, if I am an operator or an enterprise network and I want to deploy NAT64, I really need to make sure that it works for all my user cases, right? So I really need to go away if something is going to be broken. So in the last version, I split the scenarios as a recommendation from Andrew Sullivan, I think, in scenarios that are known to work and those that may work, but only in special conditions. So what is known to work? We have a service provider, NAT64, that has also DNS64. And of course, those 2 functions can be in their network or outsourced. Then we have the possibility of 464XLAT with DNS64 and 464XLAT without DNS64. So those are the 3 main scenarios. And then we have other 3 scenarios that will work only under certain conditions. I think they are still valid because in some cases they may be useful, okay? So that's the reason I put them in the document. So there is a service provider that provides NAT64 without DNS64, a service provider that has NAT64 and is assuming that the host have the DNS64 functionality, and then a service provider with NAT64 and the DNS64 is in the remote network, okay? I did a comparison of those scenarios. By the way, Jordy?
Yeah.
Let me back up one if you would. Let me report on a conversation. I had a dinner last night. I think we came up with one more scenario.
And that is that you have a user that has configured their host to use for their DNS service, some public service, OpenDNS, Google, take your pick, one of them. And so when they go looking for the IPv4 only .ARPA thing, they're going to go to that. The service provider has their own DNS, and they've configured IPv4 only .ARPA in their thing. And and they differ. Okay, the resource record that you get from those things is different. So there's a scenario that I think you're going to want to comment on, take a look at in the draft.
I think this is one of the scenarios that I have considered. The point that I was going to comment right now is that even if I have only 6 main scenarios, each of the scenarios has different possibilities or super scenarios. So in total, I come out to 12 possible scenarios.
Okay.
And some of them include, I believe, if I understood you correctly, what you are commenting.
Eric Klein. Fred, I'm assuming what you mean is that the Quad A records will be different, but the A records should be the same.
Yeah, I'm sorry.
Yeah.
Yes.
Okay.
I got that correctly.
Okay.
Yeah.
Yeah, the Quad A records give different prefixes.
Right. Or in one case, there may be none. But yeah.
So to compare the scenarios, I am taking different aspects. One of them is, are there hosts validating DNSSEC? So it may be broken. Are being used literals or APIs? There is any IPv4 only host? And then can the users change the DNS configuration? So depending on those 4 questions, I make a classification looking at if each of the possible scenarios and super scenarios is good or bad for that. Okay, so if, for example, if I change the DNS, I call that foreign DNS. In some scenarios, doesn't matter. For example, if you are prepared, you have prepared your network to not use DNS64. But if the network uses DNS64 and you choose Quad 1, Quad A, Quad 9, or whatever of the popular DNS servers, it will not work. Okay, so I am looking into that. Then I look into all the possible issues. One of them, and a big section, of course, is DNS sec considerations and possible approaches. So I am looking at not using DNS64, DNS sec validator aware of DNS64, stub validator, CLAT with DNS proxy, ACL of clients, mapping out IPv4 clients. I look also into DNS64 reverse mapping considerations. I am looking also into using 464xlat with and without DNS64. What are the implications of each case? I am looking also of what I just mentioned. If the users are changing the DNS, what happens? Questions about DNS privacy, like for example, DTLS, Quick, and so on, all the new mechanisms that may impact the performance or the usage of these scenarios. I look also into well-known prefix versus network-specific prefix usage, IPv4 literals and APIs, IPv4 only hosts or applications, CLAT translation considerations. Then I have a summary of the deployment recommendations. I have also a small section that tells basically the scenarios reported here are generally the same if you are an ISP or you are a big enterprise network or even a small network. I mean, basically the consequences of how you are doing are the same. And then I have 3 annexes. One of them is an example, a specific example of deploying 464xlat with and without DNS64 in broadband. That was an input from Fred. He wanted to know some details about how can be implemented CLAT. And then somebody suggested why not having some details about benchmarking. I am not really sure yet about that section because we may not have enough data to do it correctly. And I think that's it basically.
Okay. Mike's? Okay, seeing nobody charging the mic, we're going to do the same thing with this, have a discussion period on the list coming up in the near future. I would like to have 2 people review the draft. Can I get 2 volunteers to review the draft? Russ? The second one? Jen? Okay, cool. Thank you.
Thank you.
Yeah. And so now Fred Templin, are you in the room? I don't see Fred Templin. Huh? He's scheduled for tomorrow, but I said last time and this time that if we wound up with time, we'd bring him forward. Given that he's not here, Lorenzo, you actually asked for this slot. Can I put you to work? Huh? Not the right slides? No? Okay. What's going on here? Okay, I guess I don't have your slides yet. Okay. Well, at 1:15 p.m., I was making a Chromebook work. So, okay, do you have the slides? Okay. What? No.
Here, you take my chair.
I don't, what is it called? I don't think it's.
So HDMI.
Yeah, no.
Okay.
Okay.
Now let's see.
Yeah. Should be the last, yeah?
Okay, does this look familiar?
Yeah.
Okay, you can sit here. Now, what's going on with the slides? You can sit here.
Let's see them. Okay. Technical issues.
Look at this thing plugged in. Oh.
It's what we were. It's Fred's laptop.
Okay, weird what it's supposed
Yeah. Yeah. Height of the Fred's laptop. Probably could just upload them. Probably would be faster.
Tell me about it.
Yeah. Wait. So it's 0, huh? It's almost 0.
Okay, everybody stand in for this.
Ah, we can do that.
Yes.
Okay.
Actually, you can stay there and just, you can click on the.
Okay, all right, that's fine, whatever.
Yes, so, we, we just submitted a draft. Please ignore most of the text because there are at least two incorrect things there, which I need to fix we need to fix in 01. But the idea is, please, next slide. Yeah, the problem statement, there is still a problem of discovering NAT64 prefix because, as just been discussed, if you use DNS64 and NAT64, you might make the validated resolvers unhappy, and sometimes applications use literals, and there is 464 and so on. So it looks like we need to make hosts aware of NAT64 prefix used on the network. And next slide, please. And there are other mechanisms already standardized, but we would like to do it in array option. Why? Because you can get all information to configure the network IP related information on the host by receiving just one packet. So IP address, default gateway DNS, and now NAT64 prefix as well. It's atomic. It means you get one packet, you get either everything or nothing. So there's no way you can get in kind of incomplete state. And actually, as a network operator, I do know if there is a NAT64 translator in my network, right? I know that I either route the prefix somewhere when it could be translated or not. So network is actually the proper source of getting this information. And to run any other services, because I'm doing NAT64 and I do not want to run any additional services which I need to support just to notify hosts about NAT64 prefix. And yeah, there is a really lovely trick of asking for V4 only name, getting quad A back, and thinking, oh, it might be my NAT64 prefix. But the problem is you normally do this to use DNS sec later. It means you do not trust DNS. So using DNS first and trust the response to use DNS sec later is kind of sounds strange to me. So next slide, please. So yeah, array option. Very simple, type length, lifetime 16 bits, which similar has the same value of default router, or lifetime, I mean, have the same range, and 96 bit of prefix. So next slide, please. RFC for translation actually says that prefixes might be of different lengths, and it specifies 6 values for this, right? But it looks like use case is quite unusual for using non-96 prefix length. So in our attempt to minimize the size of the array option, we currently do not include prefix length there, so we only support /96. So the next slide, please. Open questions. So that's why we're here, not on 6 months first, not just because we just submitted the draft. Is there any real life scenario when people are using currently NAT64 prefixes which are not /96? So what would something be broken, or would it cause any inconvenience to people if the array option would support only /96? Because another possibility which we discussed, it maybe just have /96 now, and if later such use cases emerge, we can get another array option which will be bigger, because you need to include lifetime and prefix. So it will be like a 16 or 8 bytes bigger. But now we basically have a nice opportunity to simplify. We can say, okay, we have really simple standard use case of /96. If you have some very special scenario, yeah, maybe.
Well, I think I can answer your question about 96.
Yeah.
There is a network that is operating with a different length. And what it is, it has the 128 bits and puts it in the middle. That is CERNET, and they've been calling it IVI for about 10 years now. There are published RFCs on the topic. That's not the scenario you're playing with.
Yeah, so basically,
So
okay,
for your scenario, I think you're right that 96 is the way to go.
Yeah, so that's what basically question. Definitely, different prefix lengths are here for a reason. The question is, do we care about those scenarios, and shall we make array option bigger and makes everything more complicated just to cover scenarios when maybe this array option never going to be used?
And so the second question is, RFC 7205 describes a scenario when you might want to map different V4 address space to different prefixes and signal it to host. Again, it's significantly increased complexity. So I know one network which did that, and I talked to them yesterday, and they were like, yeah, you are right, we actually can do it with routing. So in most cases, you actually can utilize routing to do this. So again, the question is, would it be useful to have such an option, to do something about that? Or again, if you have such a complex scenario, you're probably not a target audience for using this array option. So we definitely need some operational input required here. And I think that's all I have. Oh, Dave.
Just to answer the 96 question, sorry, David Skenazy, Apple. From our perspective, our stack supports lengths different from 96, but we've never really tested them. And as far as I know, and I've confirmed with some people, no one has actually deployed that. So I think fixing the length to 96 for this use case sounds like the reasonable thing to me, personally.
Yeah, because my understanding is you're not just accepting this prefix and parsing it, but your resolver or whatever application is using this prefix needs to know what to do with all those prefixes, what the suffix is if it's not empty, and so on. Yeah, so that basically, yeah, it's a bit complicated, so we need to know if it was done.
Android doesn't support that either. It just doesn't support anything else than 96, period.
Jordi Palet. I read the document right before the session. I like it. Regarding the discussion of the /96, the different prefixes than 96, maybe it's also a possibility to update the document, the DNS. I don't remember. Is the 7050 document? The 7050 document about that?
No, so prefix lengths defined in whatever.
I don't remember the number.
No,
yeah.
7050 is about DNS.
Okay.
Finding DNS prefix using DNS, but /96 and other prefixes are specified in RFC for translating V4 between V6, and there are again cases when you basically put part of the V4 addresses.
Okay, but
middle,
my
right?
point, in summary, my point is maybe it's an opportunity to update that document to say this is not being used, so deprecate that part. I don't know.
I don't know, maybe someone is using it, but the question is, would those people also want to get this option in array? Because if it's, for example, a data center, when I can imagine they might want to use this, theoretically, they might not want to use this array option because everything will be provisioned statically. So that's the one about, would variable prefix length be useful in scenario when you want an array option? So, yeah.
Okay, the other comment I have been reading, but during the session was difficult for me to do both things at the same time. I was reading 7051, which is the one that do the analysis of the different options for the discovery. And I think in that document, they were comparing the array option with the DHCP V6 option. So I am going to probably later on tonight send some comments about if I find something that is really important to comment or to put in that document to somehow contrast the comments on 7051, okay? I think it's as said, I support the document, I think it's useful, but we may need some text to say, hey, in RFC 7051, this was discarded because this and that, and maybe we need to say something about it.
Again, the text is like, it was very like 0 draft and basically nothing except option format you need to pay attention to because, as I said, there are some incorrect statements in the text which need to be fixed here. And more text will be added, obviously.
Brian Carpenter, I may be being stupid, but it seems to me that the RA option has a length field, and as long as your pref64 was a multiple of 8 bits, you could use the length field to communicate its length. Sorry, if that's too. It's multiples of 8? Eight or multiple of 8
Yeah,
objects?
yeah,
Oh,
yeah.
okay.
So
Then that
length
puts a
will be-
limit on my method.
Yeah, so it will be length will be equal to 2 in this scenario. So length field is equal to 2.
Mark Andrews, one thing that
in terms of when I'd implemented DNS 6.4, there are lots of exceptions to where you don't want to do prefixing. You actually don't want to do the synthesis given either certain quad A records that are out there that are in the DNS, so you don't want to, you want to ignore those quad A records and actually do synthesis to the V4, or ignore particular V4 addresses and not do synthesis in those things. That sort of information also needs to get out there, in addition to the actual prefix. You have dual stack and you don't want to translate your internal addresses.
I won't.
The default exception is in 1918, but if you're running a different V4 network, you don't want to translate your own internal address, the addresses you're using inside the network, to quad A and stuff like that. So what I'm saying is there are other addresses where you don't want to do things, you don't want to apply translation to.
Sorry, so my understanding is there are some rules for DNS 6.4, how a synthesis should be done, right? And it's written in the RFC, so I would expect that a local resolver would follow the same rules, so there is no difference if that information is in the logic of Google public DNS 6.4 or your local resolver. And again, for example, there are cases when I do want to have my private address space to be translated because I'm deploying V6 only local network. So
DNS, the translation is more than just the prefix. There's other stuff we need to get to the hosts.
yeah, but that stuff is will be in the logic of the resolver. It's not something variable which is network dependent, right?
Can I answer Mark's
dependent.
question?
Yes, it's network dependent.
Can I reply to Mark's comment? David Skenazy, Apple, speaking as author of our CD 305, which is Happy Eyeballs V2, how to handle this on hosts. I suspect that what you're describing are some networks that have these things. Today, those networks do not have a way to communicate that to hosts, and whatever Android and iOS does is broken on all those networks today. I don't think that's something we need to fix right now. I don't know if those networks exist. If you want to fix that problem, I think that should be in its own draft. Because today, what Android will do is, if it wants to talk to that V4 address, it'll synthesize it. The network has no way of telling that Android device in that 464X or the CLAT that it only applies to these things. Regarding the problem that this is trying to solve, which is the common deployment of NAT64 in cellular networks, this really solves the problem really well.
Well,
I can translate it into where I can't speak as well if you want. Would you like me to do that? What you're proposing already exists in all deployed mechanisms currently to do this. So the only other one that we have at the moment that's deployed, I hesitate to say implemented even, is 7050, and it has exactly the same problem. And yeah. Let me also suggest a solution for this. I believe that a solution would be, if your network is V6 only, then you delegate all of this to the network. If you have no V4 locally, now you are a resolver, you're in the middle, you don't know what you have, you don't know what the client has, but I'm at the edge. If I don't have V4, then everything has to be translated. End of story. So basically we could say this is only going to work ever if you have a V4 address, disregard this.
No, dual stack local is a scenario where you want this to work as well.
But we don't have to configure it like that.
No.
Let's say that I don't have, let's say that I don't have a V4 address, because that's actually quite common. Do you agree that in that case, then we need no more than this? Or is there something I'm missing? That's my question. It doesn't work. So, like, we don't need to configure.
If you're,
Sure, I'm holding it wrong.
it-
I was already holding it wrong.
yeah, if you've only got a V6 address and no V4, yeah. If you translate 1918 addresses, you're going to go somewhere bad and down to, yeah. But when you got a dual stack internal network and you want to try to pull this stuff back to the host, we need more information than this gives. And it would be nice to try and put that either into this option or into a set of compatible options.
So what you're describing is a network that as a production configuration provides both IPv4 and NAT64, which, no, to the leaf. And I don't think that's actually a reasonable configuration.
Yeah, I don't understand why you would ever want to do that, David Scanazi.
Well, maximizes entertainment. I mean, for a mock-specific issue, it seems like yet another RA option or something that provides a URI to the thing that says what you can and cannot do. But it seems, but it seems it seems like that would be a new option and orthogonal to this.
It could be, or it could be combined with this.
Yeah, I think that having a separate one would be cleaner and.
Yeah, I'm just
Yes,
saying, when I implemented DNS 6.4, I had to consider all these scenarios and include all the different links and what go into the suffix, everything else like that. So
It's in the middle.
yeah.
I think as an author, I guess I would say we're going to go ahead and basically say you can only use this if you have no V4 on that network. And if you grow a V4 address, you turn it off. I mean, that's what we do today. If we basically grow a V4 address, if there's a network that somehow provides both NAT64 and V4, if V6 only wins the race, we turn up CLAT, and then if V4 address appears, we turn it off. So
So basically an applicability 2 sentences.
yeah, but it's also like saying, look, there's this problem, and application,
Okay, so
implementation
I
should turn it off.
suggest you make sure that it's in the draft.
Yeah. Well, I mean,
Dave, you've been waiting.
So agree with David Scanazi. Agree with what Lorenzo said. That's what iOS does today. We have a V4 address, all the NAT64 stuff is disabled. And I think that should be here. And I just wanted to say that I really support this draft. This makes a lot of sense to me, and I think this work should move forward.
Can you just please explain how you can do the destination-based synthesis with the routing?
No,
You said that it is trivially can be implemented by routing. So can you just explain to us how we can do that trivially?
no, but what I mean that the only use case I know when people using multiple prefixes and I'm mapping this V4 address space to this V6 prefix and another with part of my V4 address space and another prefix, it's because my islands do not have V4 connectivity, but they have V6 connectivity, and I want to make sure my traffic goes to the right island. But it basically means you can have more specific than /96 in your V6 routing table and route and using still the same V6 prefix, but have more specifics in your routing table.
Yeah, but this isn't the same problem that is trying to be solved there. For the destination-based NAT64, the assumption is that you have multiple NAT64 instances in the network, one, for instance, for reaching your own internet services within the service provider, and you have another NAT64 instance, which is, for instance, to reach the internet servers on your GNTFS, for instance. And then you are configuring two distinct NAT64 prefixes for those. And then when you are doing the address synthesis, you need to be sure that when the packets are sent by your host, and then on the appropriate instances and not the wrong one. So that's why in the RFC 7225, there's all this discussion about the destination-based address synthesis, and this is also discussed in the RFC 7051, which just recommend again the AR option, also the DHA option, which was also proposed by Jordi and so on. So I think that's the problem is a little bit complex. It is not just the specification is not already there for fun. It's there to solve some of the problems that was actually through during the specification of the NAT64, for instance. If you wanted to do the NAT64 with something which is checksum neutral,
In that way, you need to have something which is the suffix part in order to nullify what you are doing with the prefix size. So that's why in the RFC 7225, we have this kind of specification there, so that if someone in the world, I don't know who will be, want to have the net64 function which ensure and preserve the checksum neutrality, it can do that with that kind of specification. So this is not only for, I would say, for fun. This is something which is motivated there. And there are multiple RFCs who analyze all of this stuff. So I think that we have to be really careful about revising the consensus that we have achieved in the IETF for the prefix discovery. There's a lot of documents there. So please do at least a serious analysis for this topic before claiming that that's going to be trivially implemented, for instance, by writing and so on. So that's only my comment.
So can you explain how that differs from routing more V6 specifics on your network? Because you basically the V6, the NAT64 prefix gets stripped when you hit the NAT64, right?
Yeah.
Right. So the problem is that you want to reach for different V4 destinations, different NAT64s, right?
Exactly, yeah.
So those V4 destinations are contiguous blocks.
Which one?
Well, in 7225, those V4 destinations are specified as contiguous block prefixes.
There are multiple blocks there, so it's
multiple contiguous blocks, right? So those contiguous blocks, take each one of them, they're also contiguous blocks in V6 space. Because the thing's at the end, right? So they're contiguous blocks in V6 space. Therefore, if you only support the V4 address at the end, all your contiguous V4 blocks are contiguous blocks in V6 space, and therefore you can just route those blocks in V6 space while there's still V6 packets to the right NAT64. Once you got to the right NAT64, the NAT64 just takes off the prefix and converts it to V4.
But this isn't the problem.
What is
the problem? Is the for instance, imagine
that's what when we did read.
So Lorenzo, you realized that what you just proposed required a prefix that was longer than 64 bits and shorter than 128.
That's right, because it's up for address assignment.
Yeah, this is the problem. And let's consider that you receive a SIP communication. In your SIP communication, you have this DP part. In this DP part, you have some the connection line in which there is an IP address there. And it happens that the IPv4 address, which is in this DP part, is your internal proxy server. And you want to synthesize this IPv4 address to transform it into an IPv6 one. So which IPv6 prefix that you will use to do that? It is not a matter of contiguous routing entries or forwarding entries. It's a matter of which prefix should I use so that I will end at the end of the day to the correct IPv4 server, which is behind the NAT64 instance.
No, like I said, if you want to get to that server, all you need to do is basically route that specific block to that NAT64.
Which block, Lorenzo?
The one that contains the IP address that you're trying to reach.
Which one?
You know what the destination is, right?
Yeah, the destination
is IPv4 address.
The destination is an IPv4 address.
Yeah.
So I receive it. I am a handset. I receive that IPv4 address. Now, I need to send an IPv6 packet to that IPv4 address.
Right.
So I need to transform my IPv4 address into an IPv6 one.
Yeah.
And the hack here is that I should not send that IPv6 packet into my J interface, but send it to an internal IPv4 proxy, which is behind another NAT64 instance.
Right. But I don't understand. Yes, I get that.
That's the definition of what we are talking about, the destination-based NAT64. So that's to make sure that we are talking about the same problem here.
But the network can take care of that. If the prefix is at the end, yes, it can. All right, let's.
No, it cannot.
Okay, let's take this offline.
Okay, so thank you, Jen. Fred Templin, you walked into the room. I asked for you earlier and you were out of the room. So question, we can do your talk tomorrow morning and you can have longer time. What we've got left in this slot right now is 15 minutes. Can you do your talk in 15 minutes and do it now, or do you want to do it tomorrow morning? Okay.
Okay, so this draft is titled Multi-Addressing Considerations for IPv6 Prefix Delegation, also known as IPv6 Prefix Delegation Models. So why multi-addressing? RFC 79034 discusses recommendations for providing hosts with multiple global IPv6 addresses. Some of the benefits include privacy addressing to prevent tracking, supporting multiple processes on the same device, extending the network through tethering, running virtual machines on hosts, supporting transition technologies, future applications such as per application IPv6 addresses, and to avoid continued dependence on network address translation. The methods that were discussed in 79934 were stateless address auto configuration, DHCPv6 address assignment, and DHCPv6 prefix delegation. But of these, only prefix delegation allows multi-addressing without disturbing other nodes on the upstream link. In other words, on the upstream link, there's no multicast listener discovery or duplicate address detection needed. The goal in this document is to document the multi-addressing models for IPv6 prefix delegation. So there's many different prefix delegation alternatives. DHCPv6 is the primary example, but there are other examples, including the PIO exclusive proprietary IPMs, network management, and static configuration. We want to look at the classic routing model when the node that provisions the delegated prefix to downstream attached networks, for example, a tethered Internet of Things or internal network of virtual machines, etc. Multi-addressing host models when the node uses the delegated prefix for its own internal multi-addressing purposes. So case one, the classic routing model. Here we have the requesting router receiving a delegated prefix that distributes to its downstream attached networks. Again, it's useful for Internet of Things. Example would be a cell phone with tethered external network, for example, Bluetooth devices, a laptop with an internal network of virtual machines, or a home network router with home devices in the home network. Case two, multi-addressing on virtual interfaces. In this case, the requesting node assigns addresses from delegated prefixes to internal virtual interfaces like a loopback without invoking multicast listener discovery or data on the upstream interface. This would allow the node to have unlimited numbers of addresses available. An example that can do this is any host with an internal virtual interface on which addresses can be assigned. Example is a loopback again. Case three, multi-addressing on the upstream interface. So the requesting node assigns addresses from the delegated prefix to an upstream interface over which it received that prefix delegation, again without invoking multicast listener discovery or DAD. Unlimited numbers of addresses are available. And for example, any host that cannot assign addresses to any other interfaces besides the upstream interface. So remember, addresses are assigned to interfaces. And if the only interface you're able to assign addresses on is the upstream interface, then that's what you have to do. And finally, case four, application addressing. Here, the requesting node assigns addresses from delegated prefixes to its local applications, where each application acts like a virtual interface for address assignment as required by RFC 4291. Again, unlimited multiple numbers of addresses are available, and it provides a new model with the distinct benefit that a unique address per application may obviate the need for port numbers in the future. And that's a very important distinction. Imagine not having to deal with TCP and UDP port numbers any longer. Changes since IETF 101. We clarified that the classic routing model applies to both external physical networks and internal virtual networks. We dropped the discussion of weak and strong end system because several comments pointed out that it may not be applicable in this context. We added discussion on address per application, added discussion on relation to RFC 7934 and 8273. And we received list comments on 6/15 and 2018 and posted proposed resolutions a couple days later. We'll be folding those resolutions into the next draft version. Draft history. The first version of this draft was posted in November 2015 and announced to V6OPS. Several rounds of comments came from a review team that looked at that document. We presented dash 15 at IETF 101. Again, we had working group comments and list comments on that. Draft 19 was presented at IETF 101. In that presentation, IETF 101, it was a virtual presentation with no time for questions afterwards. But significant comments did come on the list afterwards. We're now in draft version 2.21, and now incorporates a version by version change log, and there you have a link to the document. And we'd like to ask now if this could become a working group item. Eric Vac, Fred, what is the real purpose of this draft? Is documenting use case, or are you proposing use? It's documented the cases of what can be done with the delegated prefix, the classic routing model, the downstream interface assignment, the upstream interface assignment, and the per address assignment. Okay, thank you. Yeah. For application assignment.
Following on to that question, there's no proposal to change anything in any protocol at all. This is just documenting use cases.
That's right. It's documenting use cases, although the assigning addresses to interfaces may be an implementation detail that's not well accommodated in existing systems.
How many people have read the draft? Of those people who've read the draft, could anybody maybe have a hum? And the two options will be, if you think it's useful and we should progress it, maybe think about adopting it, hum. And then the second hum I'll ask is, if you think it's dangerous and we should not, then hum. So this is the first question. Hum if you think it is useful, we should consider progressing it. Okay, second question. Hum if you think it is dangerous and it should be not suppressed. Okay. It's not the opposite question?
That's not the inverse of the first question.
Okay. Let me ask the question the other way.
So the inverse question is, who does not think it should be a working group item?
Yes.
So if you think it should not be a working group item, please hum. Okay, so.
It sounds like, take it to the list? Or?
Yeah, we'll take it to the list, which is what we're supposed to do anyway. We'll do for a call for adoption on the list. But yeah, I think there was some support for adopting.
Yeah, there was some support and some opposition.
Yeah. Okay, so thank you. It's now 3:24 and the meeting ends at 3:30, so I think we're done for today.
It's that, or someone could sing.
You want to sing?
No.
Okay, we're done for today.
Thank you.
We're meeting tomorrow morning. We have two drafts that are going to be discussed. They're both essentially any other business items from Interior. So Eric Funk has one and Patterson has the other. So. By the way, we need the blue sheets back. Where are they?